I should have had the WebAssign. Do I have to pull it up?
So it's okay. I can just read it to you.
Perfect.
8x squared plus 7xy minus y squared equals 6.
Good. Did you look at the ones we did in class?
Yes. Yeah.
Okay. Perfect. Perfect. So we can, for this situation, we can find, we can solve the equation for y. We can. But it will have the square root because I have to use the quadratic formula. It will have whatever plus or minus the square root, and it gets more complicated. Why would I bother? There is no need. But for this one, I can. I can find y. There is no need, so we are asked to find dy over dx, which that's very clear. It really tells us that we have to determine the derivative of y, meaning, again, that y is a function of x. And it has to be treated as a function. So when I differentiate the first piece, I get 16x, and it's done, plus 7. Now this is function 1, and this is function 2. I leave 7 alone. It can wait patiently. I differentiate the first function, I get 1, because it's just plain x, and then multiplied by y, but plus, I copy the first function, and I differentiate the second one, and then since I don't have it, I don't know what y equals to, I have to write dy over dx. Any questions so far? Okay, and then minus. I have to bring 2 down. I multiply by y raised to 2 minus 1, and then I have to multiply by the inner function prime, and the right-hand side will be 0, because when I differentiate the left, I have to differentiate the right, and when I differentiate 6, I get 0. Any questions so far? At this point, I'm going to distribute the 7. So 16x plus 7y plus 7x dy over dx minus 2y dy over dx equals 0. These two terms will wait. These two terms will move and change their sign. And I will factor out dy over dx. So dy over dx, the right-hand side will be negative 16x and minus 7y. And the inside is 7x minus 2y. Is it done? No, because I have to solve for dy over dx. The only thing I need to do is divide this by this. So dy over dx. Any questions? Can you tell me what was the problem, or what was the difficulty, so I know?
Well, I feel, well, I got an answer which is clearly different, but I think a difference is I didn't like put the 7 aside in the beginning, so I ended up with 23x plus 5y times dy over dx equals 0, and yeah, so I think I just like did something wrong with distributing the 7 or something. I don't know.
23y?
I have 23x because, I don't know. I probably just did something really stupid. I don't even understand how I got it now looking at it after you did that. But
no worries. Is this better now?
Yeah, well, let's see what website says. That's always the case.
So what I'm saying is, without redoing the problems we do in class diligently till you can reproduce them with no help, you should not attempt homework. That's my suggestion. I would not attempt homework. I would not even open it before redoing each and every problem many times as I need till I understand all of them. Because that's the preparation part. Any questions? Anything else for me? Anyone? Other questions? Anything?
Yeah, I have one.
I'm ready. Yes? Anything?
It was fine.
So, Alden, is this okay? Every step?
Yeah, it's fine.
Okay, good. Ken, sorry.
Yeah, it was differentiate secant theta times tan theta.
Secant theta times,
Tan theta.
we just want to differentiate the product?
Right, yes.
That's it? Okay,
Yeah.
perfect. So remember, if we differentiate a product, we have to have a sum of two terms. Secant prime is secant tangent. And then I have to multiply by tangent. And then plus. I copy the first function times the second function prime. Oops. In my mind, I already multiplied. So tangent prime is secant squared. So what I would do next is factor out, because I see these two terms have a common factor of secant squared, of secant theta. And then I have tangent squared plus secant squared theta. And I recommend, these are very important identities, so let me refresh your memory on three identities. Sine squared theta plus cosine squared theta. Does anyone remember what does this equal to?
1.
Excellent. Now remember, it's very easy. If you divide both sides by sine squared, you will get 1 plus cosine over sine, which is cotangent squared, equals 1 over sine, which is cosecant squared. And this is an important identity coming out of this one. Now if I divide the same one, this time by cosine squared x, sine squared over cosine squared x will be tangent squared x. I mean theta. Cosine squared over cosine squared will be 1, and 1 divided by cosine squared is secant squared theta. So if you remember, I said always cosecant and cotangent are linked, and secant and tangent are linked, are together. So coming back here, look what happens. If I replace, I don't really have to do that, but WebAssign may ask me to simplify it fully. So what I can do here is replace secant squared by this. And then I will have tangent squared plus 1. I don't know if that's exactly what they want, but I have tangent squared plus tangent squared, which is 2, tangent squared theta plus 1. Or just leave it as is. Since nothing else follows, I wouldn't kill myself over this. But in the previous example, and I'm reaching in my recycle bin, we talked about it, whether we needed to simplify this fully, and the answer is absolutely yes. Because a function like this will pop up in the next chapter. Even a function like that may pop up, but those are more frequent. Very good question, thank you. Anything else? Anything else? So please remember these identities together, because these two are a byproduct, if you want, of the basic one, of the Pythagorean identity for trig. Okay? When we divide both sides, and always remember the C ones are always together, and tangent is always together with secant. Good. Anything else for me?
I have another one.
Please do.
The function is t times cosine t plus t squared sine t.
So this is f of t, and we want to differentiate.
Yes.
Perfect. So in this situation, we observe that we have two products. So we will have to apply the product rule twice. So this is function 1, and this is function 2, function 1, and this is function 2. So then f prime of t will be first function prime, 1, times cosine t, plus the first function, multiplied by the second function prime, negative sine t. Please make sure that you do not have the multiplication symbol and the negative symbol without being separated by parentheses, please. Plus, I differentiate the first function, I get 2t sine t, and then plus, I copy the first function, but I differentiate the second one. I try to simplify and at least combine like terms if I can. And the cosine t is by itself. Negative t sine t plus 2t sine t, this will become positive t sine t. And no one can do anything to t squared cosine t. And this is it. Any questions? Anything else? Anyone? Okay. Anything else?
I have a quick
Yes. Yes.
general question about
Yeah.
the homework. So
Yes.
in order to get full credit, we only need to get 60% of the.
Yeah, I would like you to get. Yes, I did give a full credit for roughly 60 and above, but I think everyone should work for much better, and not just rely on that. But yes.
Okay.
Because I know it's not very pleasant. For some of you it is, but for others sitting in front of the computers may not be the best. And we will have an assignment, a written assignment that I promised to post on Monday. I think Donnie reminded me, but I forgot. It's not due till the end of the chapter, but I would like you to start working on it because now we have almost all the information. So it's not late at all, but because we still have logarithmic differentiation before you can work on everything. But yes, we will have a written assignment that needs to be uploaded. Anything else? Okay, I would like to look at a problem that states, so we are still in 3.5 and we will start 3.6 after one more problem. Okay, we are given the equation x squared minus xy plus y squared equals 3. And this is a rotated ellipse. Which means it does not have the axis parallel to the x and the y axis. That's fine. Find the point at which this ellipse crosses the x-axis. So find where it crosses the x-axis. And then it says, show that the tangent lines at those points, at these points, are parallel. Show that the tangent lines at those points are parallel. Okay. How do I determine where a graph crosses the x-axis? What do I have to find?
When y equals 0?
Thank you very much. Great job. That's the x-axis condition. Very good. Awesome. So 0 here, 0 here. Couldn't be easier. which method do I apply now to find the points? So the 2 points will obviously have a 0 for y. What method I apply here to find x? Anyone?
Square root both sides.
Thank you very much. So we get x equals plus or minus the square root of 3, so negative the square root of 3 and the square root of 3. So the first part of the problem is finished. We found the points where this rotated ellipse crosses the x-axis. Now it's asking us to show that the tangent lines of those points are parallel. What do we know about parallel lines? When 2 lines are parallel? Very good, awesome. Thank you. So 2 parallel lines or parallel lines have the same slope. So parallel lines, slope 1 equals slope 2. Okay, perfect. But how do I determine the slope? You can say plug in this. In what? What do I have to find in order to determine the slope at that point? What should I do and how should I do it?
You could put the positive, negative root 3 back into the original equation, find the y value for that, and then plug it into the y plus minus plus b slope form.
But I only have 1 point. And I don't have the slope.
You differentiate the equation.
I have to find, thank you, I have to find dy over dx. Without dy over dx, I will never be able to find the slope. In dy over dx, after that, I will plug in the square root of 3. I will plug in the negative the square root of 3, and the numbers must be the same. If they are not the same, then I have to go back to the drawing board.